In today's video, we're going to explore the fascinating topic of why objects appear to be the colors that we see. This seemingly simple question has a lot to do with the way visible light behaves and how it interacts with different materials. First, it is essential to understand that what we call visible light is actually composed of a full spectrum of colors. These colors range from red, which has the longest wavelength but the lowest frequency, all the way through to violet, which has the shortest wavelength but the highest frequency. To remember the order of the colors in this spectrum, a helpful acronym is ROY-G-BIV, where each letter represents a different color: red, orange, yellow, green, blue, indigo, and violet. However, it is important to point out that white and black are not included in this spectrum. White light is created when all the different wavelengths of visible light are combined together in equal measure. On the other hand, black is not a color formed by wavelengths. It is simply what we perceive when there is a total absence of light. So if no light is being emitted or reflected, the object appears black to our eyes. The specific color that an object appears to us depends on two main factors: the types of light wavelengths that are hitting the object and the inherent physical properties of that object. Together, these two factors determine whether the incoming light rays are absorbed, reflected, or transmitted, and this interaction ultimately decides the color that we perceive. For example, some light rays will be absorbed into the material, others will bounce off the surface and be reflected, and in certain cases, light can even pass through the object, a process known as transmission. Let us consider opaque objects first. Opaque objects do not allow any light to pass through them. A good example would be something like a cat. In such cases, all the wavelengths of light that hit the surface are either absorbed or reflected. The wavelengths that get reflected back to our eyes determine the color that we see. For instance, if a gas appears blue to us, it is because blue light is being reflected from its surface, while all the other colors in the spectrum are being absorbed. Sometimes, objects reflect not just one specific wavelength, but a combination of several. These combined wavelengths interact to create what we perceive as a particular color. Take a piece of cheese, for example. It might look yellow because it reflects yellow wavelengths specifically, or it might reflect a mix of red and green wavelengths, which combine to create the appearance of yellow. Now, let us shift our focus to transparent and translucent objects. Unlike opaque objects, these types of materials allow at least some light to pass through them. Transparent objects, such as window glass, are almost entirely see-through because they transmit most of the incoming light. Very little light is absorbed or reflected, allowing us to see clearly through them. Translucent objects, like frosted plastic or certain colored bottles, only allow some of the light to pass through. The degree to which they transmit light affects how clearly we can see through them. The perceived color of a translucent object is based on which wavelengths it transmits the most. For instance, a green plastic bottle may look green because it transmits green wavelengths better than others, while absorbing or scattering the rest. This selective transmission means that more green light reaches our eyes compared to any other color, so we interpret the object as green. Now let us examine color filters, which are designed to selectively block certain wavelengths of light while allowing others to pass through. These filters are used to manipulate color perception and are common in photography, theater lighting, and science experiments. They function by transmitting only specific wavelengths and absorbing all others. Primary color filters are those that allow just one of the three primary colors, red, green, or blue, to pass through. For example, if white light, which contains all wavelengths, passes through a green filter, only the green wavelengths will get through, and the rest will be blocked. So if you look at a white piece of paper through a green filter, it would appear green because only green light is being reflected and reaching your eyes. Conversely, if you look at a blue object through that same green filter, the object will appear black because the blue light is absorbed by the filter and does not reach your eye. There are also filters for colors that are not primary, such as yellow or indigo. These non-primary color filters work a bit differently. They allow light that is the same color as the filter to pass through, but they also permit the transmission of the specific combinations of primary colors that, when mixed, produce that color. For example, a yellow filter allows yellow light to pass through, but it also permits both red and green wavelengths, since red and green light together create the perception of yellow. Similarly, an indigo filter will transmit indigo wavelengths, but also allow blue and red light to pass through, because when blue and red combine, they form the color indigo. To sum it all up, the color we perceive in any object is the result of a combination of the type of light striking the object and how the object handles that light, whether it reflects it, absorbs it, or transmits it. Opaque objects show us their color through reflection, translucent objects through transmission, and color filters control what we see by filtering out specific wavelengths. Understanding this process not only helps us grasp how we see colors, but also gives us insight into broader topics like light behavior and wave interactions in physics. Anyway, that covers everything for this lesson today. We hope the explanation helped make things clearer. If you found it useful, please consider giving us a like and subscribing to the channel. Thank you for watching, and we will see you again in another video very soon.